Alright, welcome everyone to part 2 of lipids, in which the topic is medium chain triglycerides. So, MCTs are medium chain triglycerides or triacylglycerols. They refer to a mix of triacylglycerols of saturated fatty acids with a chain length of 6 to 10. So remember, hexa refers to 6, octa to 8, deca to 10. So hexanoic acid has 6 carbons. Octanoic acid is 8 carbons, and decanoic acid is 10 carbons. The C8 is also known as caprylic acid, and that is a very important medium chain triglyceride. So medium chain triglycerides are essentially found in coconut oil and dairy fat. In fact, coconut's 50% MCTs, and dairy fat's about 4 to 12%. The purest form of medium chain triglycerides occurs when you hydrolyze coconut or palm kernel oil, then you filter out the medium chain fatty acids and then reesterify them. These oils are generally a 50-50 ratio to 80-20 ratio of octanoic and decanoic acid, or caprylic acid and capric acid. Now, medium chain triglycerides, what's important about them from a sport nutrition standpoint is that they do not require a transporter to go into the mitochondria. So if you look at long chain fatty acids here, they require a transporter, essentially carnitine palmitoyltransferase. So essentially that's important because that means that it is limited, and it's limited primarily by the hormone insulin. So when insulin's high, you can't transport long-chain fatty acids very well into the mitochondria. However, medium chain triglycerides, as you see here, are not limited by a transport mechanism. They can diffuse from the plasma into the cytoplasm and into the mitochondria. Now, one thing I want to point out is that fat oxidation of medium chain triglycerides is greater than fat oxidation of long chain fatty acids. So these are preferably oxidized over storage. You can see here there's fat oxidation on the left side. Fat oxidation is higher in the medium chain triglyceride group. Also, we see that energy expenditure is greater acutely. With the medium chain triglycerides. Now, if you look on day 2 of supplementing, basically 40% of the energy with, as fat for medium chains versus normal fats or long chain fatty acids. Notice that energy expenditure is higher on day 2, as well as fat oxidation is higher on day 2. However, if you look at day 28, these effects do seem to be blunted. However, they're still visually there. So the thermic effect may slightly decrease over time. However, the fat loss remains. This study, you can see that fat loss was greater in the maintenance diet, essentially when you had medium chains compared to long chains. Real good study here. They had nearly 100 people, ranged from 20 to 58. They were put on a calorie deficit and asked to consume 60 grams of fat a day from normal long-chain fatty acids, or MCTs. The rest of their diet were from fibrous carbs. Notice that the medium chain group lost about a kilogram or more than a kilogram more of fat. It's about 2.2, 2.4 more pounds of fat. Now, one of the things I want to point out about ketones is that they are very satiating, and that's a mechanism they can help with weight loss. The reason why they're satiating is they get converted to an alternative energy source called ketones, or ketone bodies. Basically, in order to oxidize fatty acids, you have to have a sufficient amount of oxaloacetic acid. Okay? Remember, oxaloacetic acid binds with citric acid in the Krebs cycle to form the first step that you actually have. Excuse me, oxaloacetic acid binds with acetyl-CoA to form citric acid. So if you don't have oxaloacetic acid, where's acetyl-CoA going to go? Can't get completely broken down. So an excessive supply of acetyl-CoA results in increased ketone body production, as happens for medium chain fatty acids as compared to long chain. So because they're oxidized so fast, you notice that they're overwhelming the system. You get more ketones with MCTs than long chains. You can see that here. Subjects had a fat substitute for 42 grams of saturated or medium chains or unsaturated. And this is looking at beta hydroxybutyrate, one of the BHB, one of the main ketones we look at. Notice the MCTs had a much higher level. So here's kind of an overview. Again, if you look at the Krebs cycle here, pyruvate is going to get converted to acetyl-CoA. However, you can also get acetyl-CoA from coconut oil, or any fat, as you can see in the upper right. Acetyl-CoA is going to bind with oxaloacetic acid to form citric acid. So here, when there's too much acetyl-CoA, it's going to get converted to ketones. Now here's the crazy thing. What we're looking at is oxidation rates of medium chain triglycerides alone, or medium chain triglycerides, plus 214 grams of carbohydrate. Okay? And what you see, that right there is the medium chain triglycerides alone. That's the oxidation rate, or the use of fuel of these MCTs alone. When you add carbohydrates, it actually speeds the oxidation rate. Now, if you had long-chain fatty acids, you would see the exact opposite. You see suppression of fatty acid metabolism, particularly fatty acid oxidation. However, MCTs are not reliant on insulin. They can diffuse directly in the cell, and it seems that carbohydrates enhance gastric emptying. See that here with free fatty acids? Free fatty acids is greater right there in the MCT plus carbohydrate compared to the other conditions. If you look at the graph to the right, you can see that the contribution of medium chain triglycerides is greater when it's combined with carbs and MCTs than MCTs alone. Now, BHB data supports the view that a large part of medium chain fatty acids is metabolized in the liver because ketone bodies are formed. And that's what we see here. Okay? So that's the carbohydrate, that's the MCTs alone. And again, that's the combination of the two. So we end up actually producing more BHB with the combination. One of the problems, though, is even though these are readily oxidized, they do cause gastric distress. So large doses given in study, this study gave 85 grams of MCTs before running, and it caused gastric distress. And I can tell you for sure, for those of you who are not used to MCTs, if you take even a tablespoon of it, you'll have gastric distress, for sure. So you have to start off very low, and you have to work your way up to it. To higher doses. But too high a dose is not going to help. It's just going to cause gastric distress. As you can see in this study here, the work rate was decreased with the medium chains compared to placebo. But again, that was because it was a long duration race and it caused gastric distress. However, in this study here, they compared carbohydrate or carbohydrate plus medium chains, and they exercised at high intensities, like greater than 75% VO2 max. And there's no difference in performance. You can see that performance is better in the carbohydrate and the carb plus medium chains, but no difference between the two. So in this case, the 85 grams didn't hamper performance. And one reason why we think that is because the intensity is so severe that they couldn't even be absorbed or oxidized. Some studies do seem to support the use of MCTs for performance. This is a really good study here by Osaka. They did 1 week of ingestion of food containing a small amount of MCTs on energy metabolism during moderate intensity exercise and high intensity exercise in recreational athletes. They performed 40 minutes at 60% VO2 max, followed by time to exhaustion at 80% VO2 max. So basically, they just put MCTs in their butter. If you look here, the group that had 2 weeks of MCTs had a greater time to exhaustion than the long-chain fatty acid group. Also, fat oxidation was greater in the medium-chain triglyceride group than the long-chain fatty acid group. So it took them longer to go to exhaustion at the 60% VO2 max. So this is a quote from them. Our data suggests that short-term ingestion of food containing a small amount of MCTs suppresses the increase in blood lactate concentration and rate of perceived exertion during moderate intensity exercise. So they've actually found decreased blood lactate and decreased perceived exertion, likely because they're more reliant on fat than carbs. So in summary, medium-chain triacylglycerols are composed of medium-chain fatty acids such as octanoic acid and decanoic acid. They're readily hydrolyzed by lingual and gastric lipases. The medium-chain fatty acids formed or absorbed through the portal system without resynthesis to triacylglycerol in intestinal cells and are subjected predominantly to beta oxidation in the liver and not stored as fat. Consuming MCTs at doses as low as 6 grams per day as a substitute for normal saturated or unsaturated fats increases satiety and the thermic effect of food, and this may lead to favorable change in body composition, particularly in overweight individuals. MCTs have not been highly successful in exercising conditions, except when given weeks before the session for some unknown reason. However, MCTs should be limited to no more than 30 grams per serving, and that needs to be worked up to. You might only start with 5 grams per serving. And that's the end. I'll see you for the next lecture.